And now we're going to solve a question which may appear in all types of curriculum. It's just this question that we have here. Here I assume we have a block, whatever you want to call it, a block, something, and you have this block is being it's in a fixed point because it is being this a rock here and here another one. It has its own tension. Okay. Now because it is a force of gravity is being acting on it, it means that there is a force coming downward, which is mg, and my tension 1, my tension 2. You're given that the mass is 1 kilogram. You're told to find the tension in rock 1 and your tension in the rock 2. Now, let me add something here. Let's say this one makes an angle of 30 degrees and here it makes an angle of 40 degrees. Okay? Now, of course, the tension are not going to be the same because of the angles. Okay? Now, let's find it out. Let's say solution. First thing you have to know is drawing in free body diagram, which means that you're going to draw it in an XY plane in order to see the direction of the forces. In this case, your tension is coming this side. Let me say your tension 2, and this side is your tension 1, and here downward is coming your mg. Okay, now this is your mg. Now, but here it makes an angle of 30 degrees, and here an angle of 40 degrees. Okay. Now, from here, I want to recall something to you. These two, I have to resolve them into your y and x components. So if I resolve it into my x component, it's going to be T1 cos of 30 degrees. Now you will say, what is the direction of this? You can see this coming this side, so the direction is this side. If I resolve this T2 into your x component, it's going to be T2 cos of 40. And it's going to be along that direction. If I resolve them on the y component, let me call like this, it's going to be T2, so this is T1 sine of 30. And this one here also, the direction is going upwards. The direction is also going to be T2 sine of 40. Okay? Now as I told before, if they are on the same line, they will add up. If they are in opposite direction, they will minus. In this case, I can see that I can consider along my y axis, on my y plane. Now in my y plane I have T1 is coming upwards, okay? But it's not only T1, it should be T1 sine of 30 plus. Then I have this one here which is also acting upwards, which is T2 sine of 40. Okay, both of them are acting upwards. Is equals to, in this case, you can see that these two forces are acting upwards. Let me just not say equal, but minus. Because here we have mg, which is opposite, which is acting in opposite direction. So we say mg is equals to the resultant force in the y plane. Okay, but we know that the force is equals to mass times acceleration. So I want to ask you guys, it is moving? No, as I said before, it is in a fixed point because here it is being balanced by these two tensions. So your acceleration is going to be 0. Since if it is 0, we say that T1 sine of 30 plus T2 sine of 40 is equals to 0. It's minus mg, so it becomes equals to mg. Let me call it equation number 1. If I come now to my x plane, I say that T1 cos of theta minus T2 cos of theta is equals to 0. So I say that T1 cos of 30 is equals to T2 cos of 40. Let me call it my equation number 2. Okay? Now, from here we can make T1 the subject. So T1 is going to be T2 cos of 40 over cos of 30. Now from here we can substitute this T1 into our first equation. Now if we substitute the value of T1 into my first equation, it becomes T1 from here, you can see properly my T1 here, from here T1, but T1 is T2 cos of 40 over cos of 30. Now I multiply by sine of 40. Sorry, sine of 30. Plus T2 sine of 40 is equals to what? mg. We look at sine of 30, but cos of 30 becomes tan of 30. So my T2 cos of 40 times tan of 30 plus T2 sine of 40 is equals to mg. From here. Now I can factorize outside T2. I say tan of 30 times cos of 40 plus sine of 40 is equals to mg. I divide by tan of 30 cos of 40 plus sine of 40. I divide by tan of 30 cos of 40 plus sine of 40. Now as you can see here, this one and this one, they will die. I remain with T2 is equals to mg over, say, tan of 30 cos of 40 plus sine of 40. Okay? Remember that your air is 1 kilogram from the data given, and G.
Good. Yeah.
Now, if we find the value of this 10 over this one, we get T2 is equals to 10 over 5, approximately 5. So we get that the tension number 2 is equals to 2 newtons. So now all this is the procedure.